Materials, define civilization. We have the Stone Age, you have the Metals Age, you have silicon. It is materials that push technology through. They change the whole way we live. The 21st century will also be like that. The question is, which material will dominate?
In material science, there's many exciting opportunities happening in terms of the areas of metal alloys, in terms of composite materials, in terms of ceramic materials. But the most hype today is definitely graphene.
Graphene is very exciting. It's got amazing properties. Better than many other materials we've ever come across before. We don't really know what to do with it. It's like having this treasure. We're not quite sure now yet what to do with it, but it is very, very impressive.
We are at the Nanotechnology Laboratory of Chalmers University of Technology, a clean room. The graphene flagship is a very large research project with a total budget about 1 billion euros over a 10-year period. What people tend to relate to is the strength. When you say that it's 200 times stronger than steel, what I think is most exciting is its versatility. It's only one atomic layer thick, but nothing goes through. It's a material that is halfway between metals and insulators. So sometimes it acts as an insulator, sometimes it acts as a metal. So it's a material that has properties that we are not really used to, and we are only learning how to cope with those. With this machine, we make a graphene on copper. So if the machine was in operation now, you could see a piece of copper that changes its color a little bit when you get graphene on it. But visually, it's not that impressive. Graphene itself, being transparent material, it's not very good for TV. It's not that hard. You can actually make graphene in your own kitchen, should you desire to do that. The hard part is to prove that you have succeeded.
At the moment, we're very good on the science of graphene. What we're not good on is turning that into something that's actually materially part of another product. So I think that's the make or break at the moment for graphene is, can it be industrialized in a way that it turned out silicon could be? And it's not clear that's true yet.
During the last 10 years or so, composites has really started to take hold. The demand is very much driven by the aerospace industry regarding lighter, more fuel-efficient aircraft, and composites has brought a part of that answer. So the composites strength-to-weight ratio is allowing lighter aircraft to be built. This in turn, this demand means that we have to look at different ways of manufacturing composites in a larger scale. So innovation within manufacturing composites is really important for the future. And we're at the beginning of this journey of wider industrialization of composites.
I think we're going to need more composites in our lives. And if you look at nature, how nature deals with trying to be light and strong and stiff, and these are things that you need for structures. So things like wood itself is an amazing composite material. It has sort of glue in it, and it has carbon fiber type things, and it has a lot of air. And we're going to need to take a leaf out of nature's book about this, and our composites will probably not be solid things anymore. They will have a lot of air in them. They will probably have sensors embedded in them in the same way that nature does. Nature knows, if someone pulls on you, you know you're being pulled, right? There's a lot of different sensors in your hand, a bird, a mouse. These things, they seem simple things, but they're very complex in their material makeup. So what composites allow you to do is embed sensors to know about the stresses. They can also tell you when it's damaged. They can tell itself when it's damaged, and it can heal itself. So when we go towards self-healing materials, self-sensing materials, it's not going to be monolithic, it's going to be composite. Lots of different types of different material integrated.
The most widely used composites today is very much glass fiber and carbon fiber. Then we have the ceramic matrix composites and also the metal matrix composites. So ceramic matrix composites is a niche area, but it provides interesting properties. Ceramics by nature are very brittle. By combining it with certain types of fibers, we can increase the fracture toughness. And this allows ceramic matrix to be used in certain applications like high temperature applications of jet engines. So metal matrix composites are also of interest, and the main area of interest there is regarding reducing the weight of the metal components. but whilst maintaining the strength. And in some instances, this could be up to 60% or more in weight reduction whilst maintaining the strength. I think today what we have is a great interest in manufacturing being redeveloped and a great interest in materials, in science, coming back. At the moment, it feels like we have a renaissance ongoing. We're bringing new ideas, creating innovative technologies, and this is inspiring for all generations.
So materials have always been about enthusiasm. It's not a cold, hard choice why materials get developed. Look in the history and you find enthusiasm. And why do you find enthusiasm? Because actually materials are emotional things. People pushed silicon forward because they really wanted to live in a world where computation was possible. That's what materials are. They are a dream that we've realized. Everything is possible. It's just that we have to make it happen.